Hey guys, so thank you so much for joining this AMA series. So previously, I don't know how many of you joined our design and also how many of you joined our CAE AMAs. So the whole idea is to kind of bring an awareness about a particular domain and help students to kind of get more clarity with respect to what career choices that they need to kind of go for, right? So that's the whole idea of it, because a lot of people have different questions while they pursue their undergrad, and also while they basically try to kind of get into work. So something that we are trying to do is help out engineers take the right approach, right? uh, okay, so Vatsal, okay, we have two questions. So Anup is asking, can a mechanical engineering student get placed even after wasting 2 years of his time? Absolutely, Anup. All you need to do is have the right skills, and if you have the right skills, the companies will not worry about you having a 2 year gap. You will still be considered as a fresher, but if you have the right skills, they definitely will be able to kind of take a look at it. Um, Suryakant, which software is better? So again, software related things we'll kind of get into detail, right? Let me kind of start the session with asking, Vatsal, what do you think about? So the way that I'm thinking of taking this session is basically understand. Say you've been in the EV industry over the last 8 years, 8 to 10 years, and I want to kind of understand how to build a career in the EV industry. And the second aspect of it is what are the skills that people need to learn in order to kind of build that and build build a kind of strong profile in the particular industry, right? Guys, before getting into that, how many of you are mechanical engineers and how many of you are electrical engineers? Can you just put it on the chat? Okay, mechanical design, mechanical, mech. Okay, looks like a lot of mechanical and automotive engineers. Is there any electrical engineer out here? Okay, Vinita. Okay, Vinita Bolshetti, electrical. Okay, great. Okay, Pushpendra, thank you. Super. So what we will do is basically speak about the whole mechanical engineering part of it, and also the electrical engineering part of it, Watson. So I'll basically ask questions, and you can basically kind of start thinking about how you would go about it, what works, and what are the things that people need to know, kind of in order to go into depth in particular domain. So the first question that I wanted to ask is, say if you are starting fresh, right? If you're a fresh undergrad engineer, so either you're in third year, fourth year, or you have graduated, how will you start looking at, okay, I want to get into the EV domain, and what, knowing what you know now, what will you do different in order to get into this domain right now? So what would your approach be?
Sure, Surya. So it's a really great question. So, in my opinion, I would like to consider EV as a subset of automotive domain. So, automotive is kind of industry which deals with starting from your bicycle to bus, and you can consider aerospace vehicles as well, right? So, look at the spectrum of vehicles or types of different vehicles we have nowadays. And if you look into those components of those vehicles, so there are a lot of varieties of components and uh, variety of uh, parts inside, right? And to do that engineering, there are many different skills required, and one of that skill is electrification, or we can say the uh, e-mobility or electric mobility. So that's where I see as electric mobility as one of the emerging branch of automobile, and which is a combination of electrical, electronics, mechanical, and automotive. So mechanical and automotive engineers have equal uh, opportunities in this area. How one can start? So basically they need to understand what are the skills required, and what exactly are uh, the types of uh, knowledge base required, right? So there are two things. One is which are the domain knowledge which is essentially required for getting into automotive, and what are the other skills than domain knowledge which are required. So there are two sets here. So one is fundamentals, the other is the software tools and proficiency. So if students are going into the detail of these two things, they will be able to actually able to get into this. And what is the best way to enter into this, right? So you work on a project in this area, right? So you get to know many things about a particular stuff by doing a project. So the very first thing is how a recruiter is going to notice you, right? So the recruiters, or how the vacancies, how your profile will be relevant to the vacancies which are there in automotive. So you need to build your profile in such a way that you have done at least some projects, right? So you may not be doing very advanced projects like masters or higher research graduates, but you will be doing very fundamental projects in which you highlight your skills. So uh, in short, in one word, the answer is projects. So that's where Surya students should start with. And if they are doing the step by step projects, let's say a very simple project, right? And then they come up with some idea, or some complexity is involved, some optimization is required, some kind of let's say restrictions are there, some kind of constraints are added, then they come up with a more complex engineering projects. So that's the uh, way how they can get into this.
Great, Vatsal. So one of the things that I am hearing is a kind of a trend, right? So initially in the design meeting, design AMA, I had Subramaniam Janakiraman from Scania, and day before yesterday, I had Sandesh who speak about CAE, and now you are speaking about electrification and hybrid electric vehicles and e-mobility kind of vehicles. And one of the things that all of you kind of say and kind of mention is about the importance of projects. Say, for example, the ability to work on projects that allows people to showcase their profile to the recruiters, and that's something that we have seen work very well with students, and that's something that I also agree upon. So Vatsal, if say for example in a mechanic, if there are two kind of people, right? I'm a mechanical engineer, I want to get into electrification or e-mobility or hybrid electric vehicles, or I'm an electrical and electronics engineer. I want to get into electrification, electric mobility, and hybrid electric vehicles. So let me start with mechanical engineers and ask you, what are the different domains in which the opportunities are present? So, for example, if you basically take up domains, there is battery, there is controls, there is driver assist systems, there is motor drives, motor, and so on, right? So as a mechanical engineer, what are the different opportunities available? And as a electrical engineer, what are the different opportunities available?
Yes, sure, Surya. I will answer this question. So, one thing I would like to bring to everybody's attention, especially students, that any particular project or any particular product is the outcome of multidisciplinary engineering. So, you guys may be thinking of, let's say, a cell phone is an electronic engineer's part, right? So, mechanical engineers never do anything related to cell phone, right? But no. So if you go to, let's say, Samsung or Apple, right, there will be mechanical engineers, there will be designers who will be doing some kind of test for, let's say, IP65 or fall test, right? So uh, there are all engineers required for a single product, right? And automotive is all about integration of different things. So when we are talking about EVs and HEVs, so there are various domains of it, right? And yes, there is a separation for electrical and mechanical engineers, but they have to work together in order to come up with the best solution. So it's very important for mechanical engineers to know few things about electrical stuff. It's very important for electrical electronics engineers to know few things related to mechanical engineering. So for example, let's say I am electrical engineer and I have designed a motor which is giving, let's say, 10,000 rpm highest. But now for my vehicle to run at, let's say, highest 100 kilometers per hour speed, how much is the how much is the gear ratio required for the reduction, right? So if I do not take care of the reduction gear ratio or the power transmission from motor shaft to wheel, i I probably will not do justice to the motor design, right? So the motor designer needs to understand what is going to be the speed and torque on the shaft. This is one just a simple example. Coming to the clear definition of job roles of mechanical and electrical, what mechanical engineers do, they actually work on the transmission system. Mechanical engineers work on torque converters. They work on hybrid transmission systems. So let's say you have one source of mechanical power coming from engine, other source of power coming from motor. How do you join this two to transfer the power on wheels? Okay, so mechanical power transmission is one area. Other area is braking. So electric vehicle can have electric braking as well, but electric braking is not sufficient, right? So you cannot have purely or only electric braking. So you need to club this with friction types of brake, which are conventional brakes, right? So you need to understand how the mechanical brakes and electrical brakes will work in coordination, and which one will be applied when, right? So this is one such area. Suspension, lightweighting of vehicles, right? That is also another area which where mechanical engineers need to work. Another important area is nowadays people are uh, thinking out of the box, right? So they are not, let's say Mahindra came up with E2O, right? Which was a totally new platform for an EV. So they didn't had E2O vehicle or E2O car for which is uh, there is there is no model for IC engine vehicle. So this is the new trend where automakers are coming up with total new mechanical design platform or chassis and the body and the vehicle design platform for EVs, right? So it's not possible for you to adjust battery anywhere, to adjust the motor anywhere, to put uh, electronic stuff anywhere in the car, right? So you need to do a lot of engineering in order to arrange those components, right? So coming back to electrical engineer scope, electrical and electronics engineers will be working on design and development of electric motors, battery pack, and power converters. So these are the three major areas. Now, how do mechanical engineers help electrical engineers? So for example, I have a design of battery pack where I have more than, let's say, 2000 number of cells in a car battery pack. How do we arrange those 2000 number of cells? Now 2000 number of cells may be weighing around more than 200 kilograms. So what will be the effect on the vehicle performance if 200 kilogram of weight is concentrated in some area, right? So the mechanical design of battery pack is one another area where there will be a lot of opportunities. The other things where mechanical engineers can help electrical electronic is the thermal design. So when the vehicle is going to run at a higher speed and where there is a lot of energy required, the cooling of this stuff, right? Cooling of motor, cooling of battery pack, cooling of power converter is very much required. And how do you provide them cooling? Is it the natural cooling enough? Do you require a fan, or a liquid cooling is necessary, right? So this is the point where uh, mechanical, or I will say thermal engineers need to help electrical electronics engineers, right? So all areas are actually overlapping, right? So or when you talk about motor design, what is the output of the activity of an electrical engineer in terms of motor design? So motor designer will give you the diameters, inner diameter, outer diameter of stator and rotor, Now it's a mechanical engineers or the CAD engineers responsibility to come up with such a dimension and come up with such a material and process that material in such a way that the motor is manufactured. So the motor manufacturing is one such area where mechanical engineers will be required. So these are the domains in which there will be opportunities for both electrical and electronics and mechanical automobile engineers. But as I pointed out, these things are interdisciplinary, and students need to come out of the mindset of what is mechanical, what is electrical. I know there are very few students who will be doing their final year projects with their friends in the other branch, right? So there are almost no opportunities for students to work upon any project where they have their partners from other branch, right? So that is where we Indian students have been lagging in terms of looking at any product from interdisciplinary engineering point of view. So yes, so I think both electrical electronics and mechanical automotive engineers have equal opportunities in EV and HEV.
So, Vatsal, with respect to electrical and electronics, right? What are the fields? You did say motor design, power converters, and battery pack, working on those things. If you kind of can give an idea on what kind of work that electrical and electronics engineers will be expected in a company, that would be helpful as well.
Sure, Surya. So electrical engineers need to start with the system level design. So let's say they need to first decide what should be the voltage level of the electrical power system of a car or of a vehicle. So let's say the IC engine based vehicle, they also have a battery, and the 12 volt is a standard now. But for EVs, there is no standard voltage. So there are four electric four wheelers which are working on 48 volts, and people are trying up to 800 volts, right? So there are certain cars which have the battery pack of 800 volt system. So electrical engineers responsibilities are starting from the system level design, like choice of the voltage. They need to work upon which type of motor will be preferable, right? They need to uh, choose, or they need to select a type of the motor. They need to design that type of motor for the duty for which it is required to perform, right? So the road vehicles are not like uh, railways, right? Not like trains. So the trains will be running almost at constant speeds, right? They will accelerate and decelerate, but almost in between two stations their speed may remain, may not vary in wide range. But it's not the case with the vehicles, right? So the vehicles will go up and down with any velocity, and there will be frequent braking, frequent acceleration in urban area, right? Or even highways. So in those situation, what should be the power estimation? What should be the size of the battery pack? What should be the size of the motor? How to select the topology, right? And if they are using an AC motor or induction motor, uh, how the power can be given from DC type of battery to the AC type of induction motor, how to design the inverter, how to ensure that the inverter has been provided with the protection. And over and above this, what will be the performance? What will be the efficiency at each stage? They need to look after the efficiency of all the components, and they, these efficiencies will be cascaded. These efficiencies will be multiplied together, right? And then the overall vehicle efficiency will be uh, the final outcome, right? So let's say there are 5 stages from battery to wheel, and all those 5 stages are 80% efficient. Then the overall efficiency is less than 50%, right? Point 0.8, point 0.8, point 0.8, point 0.8. If you keep on multiplying 5 times, right, the overall efficiency will be less than 50%, right? So, and if your all stages are losing on the efficiency, then you may end up having the efficiency similar to IC engine vehicle, right? Which is not at all affordable in terms of mileage, or not at all comparable with the old technology, right? So the efficiency improvement, performance criteria, fine tuning, calibration, these are the things which electrical electronics engineers will focus on.
Great. So I've been taking some notes, so I'll just kind of, since the audience is around 70 people, I'll just share my notes and kind of go through this. So one of the so guys, I have a kind of habit of taking notes, and what I do is what I'm doing right now is kind of summarizing what Vatsal is basically speaking. So people who kind of joined a little late. So what we have been speaking is about how, as an engineer, irrespective of you being a mechanical or an electrical engineer, what is the one thing that you need to work on in order to get into your area of interest in your domain is basically projects. So you working on projects builds a lot of relevant profiles, and that kind of becomes important when you are searching for a high quality job, right? Uh, and the next thing that we discuss is the opportunities as a mechanical engineer in the e-mobility domain. So it can be HEV, it can be pure electric. What are the opportunities, right? So while electrical and electronics engineers work on full-fledged motor design, power converters, battery pack, mechanical engineers basically work on transmission systems and torque converters, mechanical power transmission. So basically, they integrate the so if you are building a vehicle, you need both mechanical and electrical engineers. So here so one of the things is power transmission. That's one. Braking. So how to combine electric and frictional braking, how to build a suspension system that is kind of light, your vehicle engineering for EV cars in order to accommodate like new battery, motor, transmission systems, and mechanical design of battery packs, like how to kind of arrange the battery packs in order to make sure the weight and the center of gravity are kind of in a particular position, and then thermal design of battery packs, like cooling of motors, power converters, battery pack, etc. Right? So these are different areas or aspects in which you as a mechanical engineer can add value to the company, and these are mechanical engineering roles that people usually start hiring from, right? So something to start thinking about. If you are an electrical or an electronics engineer, so motor design, power converters, battery packs, so those are items that you need to look into. But more importantly, you need to start learning system level design. So what is the right choice of voltage for different duty cycles, the type of motors that you need to basically take, what is the power estimation, what is the topology selection, and so on, right? So these are things that you also need to take into account, right? And so one thing that Vatsal kind of repeated was the interdependency between mechanical and electrical engineers is a little high. The reason being, there is a lot of interdependencies from a mechanical engineering point of view and an electrical or electronics engineering point of view, right? So it increases the number of opportunities available for you as an individual as well, right? So yeah, this is a summary till now. So Vatsal, if we basically look into, say, any, so if you are right now in college, right? So what are, since the whole industry is so large, right? There is batteries, there is motor. How would you start? Like, what is the starting point that you will basically take up? Is would you go for a tool approach? So basically, people speak about, hey, what is the what is the right tool that I need to learn? Is it MATLAB, Simulink, or is it like PSpice? Is it Altium? Is it something else? So people have this mentality of, okay, tool, and or then there is a mentality of, okay, understand what is going into the background, understand the concept, and then implement it in any tool that you want. So how would you go about it? And the second follow-up question for that would be, once you how would you design a domain that you would concentrate upon initially, and once you basically take that particular domain, how would you go from step one? What would be step one? What would be step two? And how do you go up from that?
Sure, Surya. So I will not recommend the students to start with the tools, right? So the software tools are uh, really important, but that is not the starting point. The starting point is what you understand and how you transfer your understanding or your level of understanding for a typical problem into pen and paper thing, and how you start calculating and how you raise the questions related to that. So the very fundamental thing you need to understand is what is the physics behind that, and what are the mathematical equations, what are the fundamental things inside the design, right? So if you really go into that fundamentals, then you will come to know about where are the challenges, where are the restrictions, right? So and then in order to solve those fundamental questions, right, you may have the approach where you do a simple calculation with pen and paper and you estimate something, right? Now those estimation will be having many assumption. Now the next level of thing can be you take up a calculator and you do the calculation repetitively for different values and try to make it iterative process and try to come up with a good numbers. The third step can be where your calculator is, or you using a calculator will be a limitation. That is the point where you should move to a software tool which is having which is actually a fast calculator, right? And it can not only solve algebraic equations, but it can solve the differential equations as well, right? And provided with the relevant assumption, provided with the relevant initial conditions. So the very first method is you ask a very layman's language question, layman's level of questions, right? And you try to understand what are the things can be challenging, where the calculations will be limited using pen and paper or using a simple scientific calculator, right? And then go back to the tool, right? So then you will understand what is happening behind the tool. And if you straightforward jump to directly learning a software tool, you may learn a software tool, but you will be lagging behind what are the fundamental concepts, right? So the fundamental concept stands first, then one can go ahead with the software tool. Now, how many software tools are available, Surya? Uh, if you talk about automotive world, right, and if you talk about simple one engineering exercise, let's say suspension design, right, in mechanical engineering, or let's say motor design in electrical engineering. So, how many tools are available? Probably more than 10,
Yeah.
50. So there are multiple number of tools which are available. Now you need to go through thoroughly on one tool, right? And if you understand one engineering application solved with one tool, you can easily work on other tool, right? There will be a different GUI and there will be a different kind of approach for that tool. But learning a tool is a secondary thing, I will say. And if you learn that tool, you will be able to easily switch to the other tool. But if you are learning any particular tool without fundamentals, it will be difficult for you to switch to other tool. It will be very difficult for you to actually know what is happening behind the software GUI, right? And someone rightly said this to this, Surya. So a software tool is as useful, or the software tool or software simulations are as powerful as the engineers are. So the software tools, they never have any intelligence, right? The intelligence or the expertise is with the person who is using that, right? Because they are made by us also, right? So they softwares are created by humans only. So there are high amount of chances that if you provide garbage input, there will be garbage output. So in order to know what should be the inputs for a typical simulation, it's very, very important to know the basics. So start with basics, get to know which tool is easy to start with, which one is user friendly, which one is popular in industry. Choose that tool, learn your software skills or software development skills, get back to your problem, right? So this should be the approach. First is you start with your pen and paper exercise, then you find a limitation of pen and paper calculation, you go to software tool, then you come back to the pen and paper thing again after taking the help of software tool, right? So I think this should be the step by step approach, and then you can decide that which uh, type of component is best, which method or which solution is going to be work out best in a typical case. So then you can compare different things, right? So you can do simulation of three different types of motor, you can do the simulation of three different types of suspension, right? And you can compare which one is going to be better and which one is going to satisfy my uh, product requirement or project requirement. So this should be the approach, Surya.
Great, great, Vatsal. So, guys, I did note that down as well. So, one of the aspects that Vatsal basically speaks about is how to go about learning really strong skills, right? So at the end of the day, that's what everybody wants in order to kind of get a particular job, right? I know a lot of people, the first thing that they ask is, should I learn this software, should I learn that software? So will I learn answers software, or will I learn MATLAB and Simulink? Will I learn Git LabVIEW? And every person has a particular software that they know about, and some of their relatives or seniors would have basically spoken about in college, right? So what we see is, and this is something that I have spoken to like multiple people across, people who work in Tesla, people who work in Rivian, people who work in some of the top companies. One thing that they basically say is, pick a problem statement, right? What Watson basically said. So that problem statement can be in any of the domain that interests you. It can be in a motor, it can be in a battery pack, it can be in a power converter, it can be on any aspect of it, right? So you basically or in controls and driver assist systems. So once you basically take the problem, understand the fundamental aspects of the problem, like understand the theory that correlates to solving that problem, right? So once you understand the theory aspect of it, and it's not, when I say understand theory, I'm not asking you to mug the theory by heart. I want you to understand the theory, right? Try and understand. Once you try and understand, then again, it is going to be the way that you solve a problem is through a particular equation. Say that is a equation for that allows you to solve that. So a great example will be a stress equation, right? Like, this is not an electrical engineering, but if it is a stress equation, then just take a pen and paper, solve that, and see what is the result that you need to have, right? And or if it is a more complex thing, use a calculator, right? So what this allows you to do is, it allows you to predict the answer correctly. So it allows you a good understanding on, okay, where the answer should be, right? Then you can basically go to, say, any tool, like, say, for example, one of the very popular tools are MATLAB and Simulink. So if you're learning the tool, now what you will start doing is, okay, here is the tool, and if I basically click on this button, or if I write this code, this is what is happening in the background. And you will know what's happening in the background because you know the fundamentals, right? So if you once you basically start doing that, your ability to use any software, like exactly like what Vatsal said, even for MATLAB, you can do things that MATLAB does in Python, what Python does in MATLAB, there is Octave, and so many more, right? But what is important for you is having the fundamental and the analytical approach allows you to understand what's going behind the software. Once you understand that, then it makes life very easy for you, because what you will do is, you will basically take your existing knowledge and use it in any software that is thrown at you. Probably for you to get accommodated with the software, it will take around 2 weeks, but that's it, right? So yeah, pick a problem, solve it analytically, and then go to a software, use the software to solve that. Again, as you start using a particular software in the initial days, at least, it is very important to come back, check again using pen and paper if the result that you are getting through the software is also the right result, right? So what this helps is, basically, it works as a check mechanism, right? It checks if what you're understanding and what you're getting is aligned, right? That is really important. And as you keep on doing this cycle, it builds a lot of confidence in you. Now at some point of time, you don't need to do step 2 and step 4. You basically have step 1 and go to a tool and start doing it, and you've been doing that. But step 4 probably will be there at every point, because you want to have a sanity check that you're doing the right thing, right? So yeah, this is great, Vatsal. Thank you so much. And let me kind of see a few of the questions. Okay, so what are other ways? Okay, Pranay, Bharat is asking, what are the other ways? So I'll take like another 10 to 12 minutes. So it's like 5:40 right now, another 10 minutes for questions, Vatsal. Before getting into questions, I also wanted to kind of understand, is there anything that you would like to kind of speak about in particular, apart from what we have spoken, in regards to approach to learning, in regards to approach to what are the domains in in electrical and hybrid electric vehicle, and what are your thoughts on how one should go about it? So if you have anything, we can basically discuss about it and then go for the questions.
Sure, Surya. So I would like to throw some light on what level of opportunities can be there in this sector. So I actually compare this technology revolution in terms of, let's say, lighting systems. So usually we used to have CFL bulbs and tube lights, right? And now if you go to an electric shop, right, probably 80 percentage of the products falls into the category of LED lighting, right? And that is how the technology has captured the market. Now, what is going to happen with automotive electrification is something going to be similar, right? Because LED lighting is more efficient, it produces a decent lighting, and there are number of players into it, right? The same thing you can see in the EV domain as well. Now, so what are the opportunities? So there are a lot of opportunities. It's not only design and development. You can think of opportunities related to, let's say, an insurance company, right? So an insurance company nowadays, they have a good kind of a synchronism where, let's say, you met with an accident, your vehicle is stuck somewhere, and you want to process or you want to initiate a claim, right? Now, how your claim is going to pass through in the system. So you upload a photograph of what is the damage happened to the vehicle, and you upload that into the software system. There will be a reviewer, right? There will be a person auditor, right? There will be a person who will be actually estimating the damage, and based on that, they will be passing your claim, right? Now, think of the same thing when it comes to the electric vehicle, right? So how about the insurance for electric vehicles? How about the guarantee, warranty, and life cycle of electric vehicles? What happens with the batteries? Those are used batteries inside an electric vehicle. So electric vehicle never consume the full capacity of the battery, right? So you might have been using your toy car battery with your remote control of a TV, right? So there is still some capacity left, right? And those cells who are not working for a toy car, they will work well for a remote controller because it requires less amount of energy. So you need to understand the entire ecosystem. So there are not going to be the jobs only in design development and engineering, but there will be a lot of opportunities in the insurance sectors, in the after sales, in recycling, and there will be a lot of opportunities in shared vehicles, connected cars, and automation of the systems, right? So the ownership of the vehicle, that will also be uh, like one of the change that can happen, right? So you do not own a vehicle, you just take a ride and you pay for a ride. So you do not own a vehicle entirely, right? And uh, this may end up in a new trend, right? So you need to understand what are the domains that will open up apart from this. So what are the level of changes that will be occurring in terms of electrical electronics engineers? I would like to say that, let's say you have a electric vehicle parked uh, at your home, right? Now you do not have enough electricity, or let's say you do not have connection from your electricity board. You can actually use the electric vehicle energy to power up your home, right? So the vehicle to grid, vehicle to home is another next technology, right? So the power battery packs for your house, right? The battery packs which are portable, right? The battery packs which are going to be replaceable, swappable, right? Those are the new technologies coming up, and there are endless number of things. So uh, and there is a lot of engineering involved over here, right? So it's not only related to inside of the vehicle, there are a lot of opportunities when you consider vehicle as a system. So when you consider the shared mobility, when you consider connected vehicles, so there are a lot of opportunities. And what is the overall market? So automotive, in terms of after sales component, right? How many times you went to garage with your vehicle, right? And how many times you changed some components, how many times the repair was required. So the repairing, maintenance and everything will also come up with multiple opportunities. So I just wanted to add about the sectors in which the opportunities are there. So I think here I have summarized, um, over and above design and development, there will be a lot of opportunities in those sectors as well.
Great. Hey, thank you so much, Vatsal, for that. I think Pranay has asked a lot of questions, so let me kind of start with say probably the last question first. From the system level to subsystem and component level, what are engineering tasks for design and development of the electric motor for a battery operated electric vehicle? What is the potential for fuel cell electric in the commercial and passenger transport?
So we'll take this question into two parts. The first is related to motor design. So Pranay is interested to know more about um, engineering task. Okay, so when you split up the motor design into an engineering problem, there are three types of designs involved. One is electric design, one is magnetic design, and the other is thermal design, right? So whenever a motor design project is going to start in any company, there will be three different categories of teams involved over here, right? So let's say the thermal team will be uh, actually asking about, uh, do you have any idea what level of losses are going to happen, and how much is amount of heat generated at a given power level, right? So they will start their work from that point, right? Electrical and magnetic, or let's say electrical design and the magnetic design, they will be also working on, let's say, uh, how much should be the length and diameter, right? Is the maximum value allowable? What is the weight to torque uh, ratios, right? What kind of things are necessary for from the point of view of materials, right? So which materials will be used for magnets, which materials for winding, right, and so on. So these are different activities that will go in parallel. I hope I address the first part of the question. The second is Pranay is interested to know more about fuel cell uh, part in commercial and passenger transport. Yes, Pranay. So this is uh, fuel cell is a emerging technology, and there are many companies working on this. Um, and basically, the fuel cell can be clubbed with battery and the ultra capacitor, and together it forms a perfect solution for energy storage. So basically, the fuel cell is going to help you to achieve the higher range. At the same time, it can be a kind of a low cost fuel, right? Where you need a hydrogen, and yet the hydrogen infrastructure is going to be a challenge, but there are many opportunities. And Toyota Kirloskar in India is one company. They are very much hopeful about fuel cell based cars as well. So commercial and passenger transport, yes, fuel cell is a good option for the energy storage.
Great. Let me look into. So Pushpin, so this question, Pushpendra has asked, sir, this year no placement season because of COVID-19. Next year no placement because of recession. Is it possible to choose some courses in Skill-Lync to learn and then create jobs for increasing number of available mechanical engineering students? Pushpendra, actually, even in COVID, we are basically seeing jobs open up. So over the last 2 months, we have basically filled in at least 10 positions. And what we are seeing right now is people like companies like Alten, and as companies start opening up, they have opened up their they have not started aggressively hiring, but the hiring has definitely started. So one of the things that we see is every time there is something out there, the companies put a very important premium on having the right skills, and that's why they even come to us, because they think people at least go through a particular coursework and they have the right knowledge. So that's one thing that we have witnessed. So I wouldn't say there are no job opportunities. I would basically say there are job opportunities. It's just that they right now they are only hiring people who have the knowledge, because they are the company's mindset has shifted from hiring and training, but to hiring a trained engineer. So that's the kind of a shift that we are witnessing, right? Um, Mohit Upadhyay, for mechanical engineering, what type of knowledge we should have on electrical and electronic components? So, Vatsal, do you want to take that? For mechanical engineering, what type of knowledge we should have for electrical and electronic components? So I think, guys, Mohit, I don't know if you were joined a little late or not, but say that's something that we discussed on. Say, for example, if you're a mechanical engineer and if you want to get into EV, right? So something that you might start working on is basically uh, say transmission systems or torque converters for electric vehicles. Basically, that's something a mechanical engineer you need a mechanical engineer to do. Mechanical power transmission systems, braking, especially how to combine electrical and frictional braking, how to design a different suspension for a more lighter vehicle or a different center of gravity kind of vehicle. Uh, that's something that you might need to work on. Vehicle engineering to accommodate new battery, motor, transmission systems. So there are new companies that kind of are coming up with their own new design of cars. So which is not a kind of a swapping, taking, they're not taking out engine and putting a battery pack. So that doesn't work. So they're not doing that. So the whole systems are being changed. So these are the different, so mechanical design of battery pack, thermal design of battery pack. So here, what is really important out here that you need to take into account is for these roles, they will not ask you to be an electrical engineer, but they will expect you to understand, say, the circuit diagrams, understand what controls means, understand how the battery management system works, understand the hybrid electric vehicle or the electric vehicle architecture. So because your interaction is going to be with electrical and electronic engineers, and in order to kind of understand what they the way that they communicate with that electrical and electronic engineering terms, you need to kind of be able to understand that and kind of provide value and design systems. So these are kind of roles that you so Vatsal, if there is anything else I missed, you can definitely pitch in.
Yes, Surya, you almost covered top of the aspect. But what I would like to mention specifically, so uh, if I give you an example of, let's say, enclosure design for a battery pack, right? So let's say most of you have a power bank, right? So you may consider the power bank product as purely electrical electronics, because there will be 4 to 5 or 3 to 6 number of cells connected inside, and there will be some kind of a printed circuit board. But it is very important to design the enclosure according to its usage, right? According to its form factor, right? How you are going to hold your power bank, how it can be accommodated, where you need to put the switches, right? What about the ergonomics of the product, right? So there are uh, opportunities for mechanical engineers as well in order to uh, finalize the product, right? Enclosure design is one such aspect, and the other I would like to emphasize on the thermal aspect. So yes, these two are major when it comes to electric mobility. So Surya, can we take up the next question?
Sure, Watson. So I think I will take up this question. Hey, I think it's from Sabarishwaran. It's about Skill-Link's Masters in Hybrid Electric Vehicle course. Hey, in the first semester, we learn electrical and electronic subjects like controls, BMS, introduction to HEV. And in the say second semester, we choose either CFD, CAE, or design. How would what kind of interviews will we be able to attend, right? So this is something, again, I'll kind of share my screen. This is something that we spoke again. So, for example, if you're taking up computational fluid dynamics in your second semester and of our masters in hybrid electric vehicle, then you will basically apply for jobs as thermal design engineers or thermal. So when we say thermal design engineers, it's basically engineers who do computational fluid dynamics on battery packs or cooling motors, power converters, and so on. Because in order to kind of have the system running in the right way, those are the things that you need to take into account, right? So these are the roles that you will be looking into as a CFD engineer. As a CAE engineer, you basically look into uh, say like structural analysis for say, for example, if you are looking into crash of a particular car, then you need to understand how. So previously, when the crash happened in a IC engine car, it usually the main goal is to kind of only save the passengers, and if the car kind of crumbles, that's fine, and until the passengers are safe. Right now, not only they need to save the passengers, they also need to kind of make sure the battery pack does not catch fire, right? So as a CA engineer, you those are some of the aspects that people are working on, right? Design engineers, again, there are multiple design aspects of it. Say if you're looking into BAW design, then you also look into wiring harness. So there are multiple wiring harnesses that come into play. So according to so as I said in the previous question, your ability to know your ability to understand the electrical and electronics aspects of it in the first semester helps you to understand what are the critical aspects of it that you as a mechanical engineer need to take into account and develop systems, right? So that's something that you need to think about. um, Give me 1 minute, I'll just go to the chat. um, Okay. Pranay, what are other ways of mad? Pranay, I know you have a lot of questions, so let me kind of go to the beginning and see if I can also answer a few others questions so that I'll basically take it. So that's like 15 to 20 minutes more. So definitely we'll take all the questions. Akshay Srivatsa, hello everyone. Hope everyone is safe and sound. As we know, the EV and HEV have a great future till 2025 to 30. So what can be done in terms of software training and knowledge gain for an early pass out graduate to start a career in this domain? Akshay, again, I don't know if you have heard about Skill-Lync, the courses that we provide. So if you're a mechanical or an electrical engineer, and if you want to kind of get into electric vehicles or e-mobility, so we do have courses that kind of provide value for a mechanical engineer and an electrical engineer. We have a master course on electric vehicle design and analysis, and master course in hybrid electric vehicle design and analysis. The approach that we take is basically to help students work on really high quality projects, right? So for example, if you go to some of our courses, what you will be looking at is so so if you basically go to some of our courses, you will start looking at people's working on projects. So all our courses are project based, and what it allows you to do is it kind of every step of the coursework, you start working on projects and you develop a portfolio of projects. So a good project that I could kind of relate to is something that one of my so Rahul Ramakrishnan. So as you start working on a coursework, you need to know three things. You need to understand the fundamentals, you need to test out your fundamentals, and you need to basically start working on applying that fundamental using a particular tool, right? So what we do is in our courses have projects like this. So for example, braking energy and braking strategy and motor losses, design of an electric vehicle, right? So if you basically speed control using H-bridge switch. So these are projects that the students work on as a part of the coursework itself. So if you are someone who is basically looking to learn real industry oriented knowledge, so you can basically take up our coursework. So as you see, we cover the theory, we cover the fundamentals, we teach what are the formulae that kind of works, and then we kind of teach coding as well to help you do the simulations, right? And these are kind of reports that you end up developing as a part of our coursework, and this kind of helps you build a portfolio if you are a fresher, and if you kind of want to make sure you make the most use of this boom in electric vehicles, right? There has not been any transformation of transport industry over the last 100 years, especially apart from these, apart from the last two to the next 10 years. So this whole aspect of 10 to 15 years, we have been lucky because this is a new industry booming, and we can basically make use of this, right? So these are project reports that you can basically take a look at. You can go in detail and understand what every student basically did in our projects. So this is in Simlink. So yeah, if you are starting up, this is something that I would definitely recommend you to do, right? Okay, okay, there are polling questions. Will the remuneration seen for core engineers improve in India? This is the main reason why most people go into the jobs in India. Like we are seeing a definite increase. So the remuneration for high quality technical engineers right now is somewhere around 4 to 5 lakh packages per year. So that's something that we are seeing right now. So Hari Krishna, if that is something that you want to kind of look at, if you have the right skills, the remuneration follows. Mohit is asking, sir, if suppose I work on electric vehicle domain and later I don't get a job in that field, then my studies and the time I spend to study will become waste. Mohit, not necessarily. If you think about it, right? So if you're thinking about learning electric vehicles, right? What you end up learning are modules like battery packs, modules like controls, modules like uh, electric motor, electric drives. So if you think about this, even if you are not getting that particular domain, so smart electronics, so all the electronics domain will have battery packs in it, right? All the mechatronics domains will have controls in it, right? It is not while the coursework or the domain says okay electric vehicle, it is more of a modular approach. It's like saying it's like saying I learned differential calculus. I do not know where to apply it, right? It's just that differential calculus and integral calculus is applied across all the physics and engineering principles. It's just that we do not know. So there are multiple opportunities in different domains, even if you are not getting into the EV domain. So something to think about, Mohit. Scope of EV versus HEV, so that it will be convenient for us to join your master courses. Dharma, if you are an electrical or electronics engineer, definitely recommend electric vehicle masters. If you are a mechanical engineer, definitely recommend hybrid electric vehicle masters. The reason I do not recommend a mechanical engineer to take electric vehicle masters is it's going to be too electronics and electrical based for him. For electrical and electronics engineer, the HEV might be too mechanical engineering in the second semester. So it's something to think about. Would mechanical engineer find opportunity in the field of model-based design of EVs and HEVs? Obviously, right? And that's what we have been speaking about. Mohit, sir, my brother is an employee in Ford Motor, and he has done his industrial engineering from Geetham and has around 4 years of experience. And now, if he works on electric vehicle domain, will that be an upgrade in his career? Mohit, so need to understand more about what he was working on at Ford. So obviously, if he's working on production, there will be definite advantage for production or design or any other thing. So that he can basically get an upgrade from his existing career. Right? What is the scope of applying HEV in India? So far, EV cars and 2W, however, with imported motor, like Pushpendra, I did not understand that question, so I'm going to skip that. On a subsystem and component level, what are the engineering tasks for electrical and thermal domain? Pranay, did we answer that question? Just nod your, yeah, okay, thank you. Abhilash, for mechanical engineering, what type of knowledge we should have on electrical and electronic components? Vatsal, do you want to answer that question for mechanical engineering? What type of knowledge we should have on electrical and electronic components?
Sure, Surya. So you need to understand the basics, right? So, for example, if I give you an idea about, uh, let's say, a single cell is going to have 100 watt hours of energy in, let's say, some amount of volume, right? So, the energy and volume are um, of our interest, right? So, if we want to have a vehicle which is having the range greater than 150 kilometers, so we need to accommodate such a size of a battery pack which will need that area. And it's not like we can keep the half of the battery pack on one side, the other half on other side, and have the wires or connecting cables in between, right? So you need to figure out some of the things where which is very much related to electrical electronics engineering, and you need to understand what is series connection, what is parallel connection. You need to know uh, what is voltage and current, right? So if you are very much thorough with your first year of basics of electrical engineering, I think that level of understanding is enough to start with, right? And then according to your domain, right, according to the area which you are choosing, right, then you can go into the detail of that particular electrical electronics. So we never recommend uh, to go through all electrical electronic concept unless and until they are required, right? So if you see our courses, they will be dealing with the electrical electronic concept which are necessary for mechanical engineers. So uh, yes, I would like to say you need to um, go. So your approach should be as in when the question comes to that particular subsystem, to that particular component, or let's say to that theory, right? Then only you need to go into that detail, right? So, for example, if you are interested to know more about the difference between a DC motor and three-phase motor, so you need to definitely recall what is a three-phase electrical systems, right? So those fundamentals are required in order to uh, address some of the mechanical design related things as well. So if you are um, comfortable understanding these terminologies, right, that's fine. So mechanical engineers never replace the electrical electronic engineers, right? So they actually aid it, right? They actually help them, right? So there is a teamwork going on. And uh, I would like to say, if you are familiar with the terminology, you will be able to better talk with your fellow electrical uh, team members, right? So I think that communication and that level of understanding for a system, that is sufficient. So you never go into very much detail, but you need to get the overview and you need to understand basics of it.
Great. Thanks, Vatsal. Um, hey, hope that answered your question. So next question I wanted to kind of take a look at is Adip Shukla. Sir, how a fresher can penetrate in the EV industry? Adip, if you're an electrical or a mechanical engineer, you need to first have a portfolio that you can showcase, because especially in the electric industry, EV industry, they are going to hire people who know about that aspect, who know, say, for example, if you're applying for battery management system, then they are going to look at battery management system, people who have done BMS, right? So it does not mean you need work experience. It means that you need project experience. So something to think about. And that's what, say, for example, projects like these kind of showcase that you already have that kind of an experience, right? So think about that. Mohit, for mechanical engineering, what type of knowledge we should have on electrical and electronics? I think that's what Vatsal basically touched upon. Um, Pavitran, I'm working in automobile industry. How can I approach OEM in off-campus for EV division? So, Pavitran, I think the same answer that I basically said before. First, develop the skill sets. Then there are a lot of opportunities in LinkedIn which come up. Apply for those opportunities, and they should basically take a look at your profile and kind of give you a go forward, right? Um, Okay, been working on EV. How can the efficiency for mechanical water knowledge? Pressure, everyone, concerned. Okay. So I think those are the pretty much we have covered everything. I'm just going to go to the end and um, Adeep, I think Adeep asked another question: why it is difficult to find profiles in companies that require model-based design engineer or powertrain engineer? When you are asking, are you saying those kind of jobs are not coming up, Adeep? Is that the question, or are you saying okay? So actually, some of the times the job roles are totally different, right? Some of the time the name of the job role kind of is different, right? And you just need to go into the description of the company, that is, say for example, Ola Electric, right? If you go to Ola Electric, they are hiring right now, and you see the job requirements, it will not say model based design engineer or powertrain engineer, it will say something else. So something to kind of take a look at. So you, when you are starting to apply for jobs, one thing that we have understood over time is that the job role is not necessarily what you expect it. For example, it might not be a design engineer, or it might not be a thermal management engineer, but it might be something like a battery engineer, right? So something to think about. um, Mohit, okay. So I think Manik Miglani is asking questions. Are why skilling courses are costlier than other courses? Like Manik, there is no other platform which allows you to work on multiple projects. The courses that we bring in are basically we spend enough time to kind of understand what is required in the industry, and kind of go back to the industry, understand their requirements and what they look for in a candidate, and develop the coursework according to that. And that's why you basically go look at any profile. So something that I can show you is basically um, so these are profiles of students who basically take up our courses. And if you think about this, you there is no other platform you can basically go to and even see these many profiles, right? So you can basically load more profiles, and you can just keep on going. And all these profiles are basically of people who are working on a particular coursework, right? And they have worked on projects. So the ability to build your portfolio based on industry oriented projects is a very very unique thing that you can do. You might know that all the companies ask for work experience, right? How do you, as a fresher or as a person who is working on something other than EV or HEV, how do you build that work experience, right? So those are the things that we basically have thought about, and built a platform that basically allows you to take these courses. And that's why like people take our courses from Brazil, from US. The reason, because they basically see that this is the only platform which allows them to kind of do that. And on top of this, you basically have one-on-one support, right? So it is not like Coursera or EDX where you go and put a comment on a forum and you wait for the answer. So you basically have one-on-one sessions where you can basically get your questions answered, and you can go. So these are profiles, right? These are profiles of students who have basically worked on projects. And if you think about this, right, these many projects, even we would not have done in our undergrad, right? And I can basically click on each project and show it, and you will see that students basically work on very high-end projects. Say, for example, if I'm just clicking on this, you will see how detailed each project is, and that is how you are going to get a job as well, right? You want to showcase what you have done, what you have understood, because your resume and your friend's resume is going to look pretty much the same, right? Because my resume and my friend's resume look pretty much the same, because it's everything is pretty much the software. We work on, say, one project at the end of the university, and there's nothing else, right? If you basically send this profile, and you need to ask, have I done this kind of a project in my undergrad, where I spent so much money, or is there any other platform which basically allows me to do this, right? So those are the things. Again, yeah. um, Madan Raj, we are not affiliated with any university, so we are not providing any degree. So it's a master certification program, and what we provide is we provide the opportunity to build a very strong portfolio that kind of helps you to kind of get a job. Um, okay, what is the necessary of ML and AI? Yeah, so Adeep, so I'm going to take another 2 minutes to answer questions. One of the questions that Adeep has is, sir, can I work on vehicle dynamics without knowing much about CAD software? Absolutely, Adeep. So knowing CAD and knowing vehicle dynamics simulations is totally different. So you need to have a good understanding on, say, for example, kinematics of machine elements. So those kind of things, and have good understanding on vehicle dynamics. So you will be able to do those simulations. So you need to understand the fundamentals, and you don't, CAD does not matter there. Rajat Shetty, since you spoke about building an ecosystem, what role building the charging infrastructure play in it? Having said that, that is something that will be generating employment in the coming future. Rajat, obviously, right? If the whole, there is at least 100 million, 100 million or 10 million. I don't know the number of exact vehicles that are being driven in the. I think it's 100 million, but 100 million vehicles that are being driven. And if all these vehicles are one day going to kind of transform into electric, and you need basically, how you see petrol bunks, you need those charging stations, right? You basically need to, you can imagine those many charging stations also being there. So um, great. So I think, so Mohit, how is computational fluid dynamics related to EV? Right? Say, Mohit, I think I answered this question before. So you have a battery pack, right? You have a motor, you have a power converter. All these basically over a period of time, as you use, it becomes hot. The heat is generated and it becomes hot. So as an engineer, mechanical engineer, what your role is to make sure this, you have the right cooling agent flowing at the right rate, in order to make sure the heat transfer is done. So that's where the computational fluid dynamics part of it comes into play. Yeah, say, I think someone is asking about placements. So over the last, I think 12 months, we have placed around 250 students, and we have placed students in Fiat Chrysler Automotives. We have placed in Ford. We have placed people in ESI. We have placed it in General Motors. Some of the top companies that you can think about, Mercedes-Benz, GK and Aerospace. So some of the top companies that you can think about, students are basically working out there, right? So uh, and the reason that we basically do what we do, right? Just to give you a background, I did my master's in University of Wisconsin-Madison, went on to work for Cummins for 4 years, and then quit the job and moved back to India, just to make sure we provide the right kind of skills, because I did not have the opportunity while I was doing my undergrad to have a platform like Skill-Lync and learn anything from that. So that's why we did. And Vatsal basically has around 10 to 12 years of experience in the industry, and he basically worked in a electric scooter startup before, and he quitting that job and moving to Skill-Lync is to kind of generate the right kind of resources that the industry is going to need in the near future. So Bhargav, yes. So basically, students who take up our courses in the US get their placement assistance in the US. Yes, Bhargav. after taking Skill-Lync course, is there a chance to get placement? So we do provide placements, Abhilash. We basically assist you in that's the whole aspect of building portfolio and going there, right? So CAE and additive manufacturing. So Pranav, there are a lot of courses in CAE. I'll definitely recommend you to take a look at it.